Welcome to our deep dive into machine learning. Looks like our listeners are really interested in where this field is headed, especially by 2025.
Yeah, it's a fascinating time to be involved, for sure.
And let me tell you, things are going to get really interesting. We're seeing this huge shift, right, from like theoretical data science to, I guess, a more hands-on engineering kind of approach.
Absolutely. And what's really cool is it's not enough anymore to just, get the algorithms.
Right.
The real magic, it happens when you can build and deploy solutions that, actually work out there in the real world. Imagine building a bridge.
Actually,
right?
yeah.
It's not enough to know the physics. You got to, get your hands dirty and build the thing.
I love that analogy. So what's kind of driving this need for this more hands-on approach?
Well, one massive factor is just the sheer volume of data. The amount of data we're generating. Did you know 90% of the world's data has been created in just the last few years?
Wow, that's wild.
Yeah, it's crazy. This data explosion, it's sparked this AI arms race across, pretty much every industry. Everyone wants to use machine learning, to get that edge.
So it's like a gold rush, with everyone rushing to stake their claim.
You got it. But to find gold, you need more than just a map. You need the tools. You need the skills to actually get it out.
Yes.
And in machine learning, those tools are hands-on engineering skills.
Yeah.
It's not just, understanding the theory, but being able to build and deploy and even maintain those systems.
Yeah.
Systems that can actually handle, the complexities of the real world.
Okay, so let's unpack this whole real-world complexity thing. What kind of challenges do machine learning engineers actually face when they're trying to bring a solution from, a nice, clean lab environment to, an actual production environment?
One of the biggest, I think, is data quality. So in a research setting, you usually work with these, nice curated data sets.
Right.
But out there in the real world, data's a mess. Let's say you're building a model to predict customer churn for a telecom company.
Yeah.
You might find that some customer records, they're missing values, really important ones, like age or income.
So how do you deal with those missing pieces? Do you just ignore them?
You can't just ignore them. That would totally mess up your results.
Right.
Instead, an ML engineer needs to figure out how to handle those missing values. Maybe they'll impute them, use some statistical techniques or algorithms that can deal with missing data.
Yeah.
This is where the engineering mindset really comes in. Knowing how to, clean, validate, and transform data into something, your model can use.
It's like being a detective, piecing together clues from this messy crime scene.
That's a great way to put it. Another challenge is scale. So a model that works perfectly fine, on a small, tidy data set might totally fall apart when you hit it with these massive data streams that are common in real-world applications.
Right.
Think about a recommendation system for a huge e-commerce giant.
Yeah, okay.
It's processing millions of transactions every single minute. Your model, it's got to be built to handle that kind of volume.
So it's the difference between, baking a cake at home, following a recipe, versus running a huge bakery.
Exactly. You might be amazing at following a recipe, but mass production needs a whole other set of skills. In machine learning, that might mean using techniques like distributed computing, basically breaking down the problem and spreading it across multiple machines to speed things up.
You mentioned distributed computing. For people who maybe aren't that familiar, could you explain what that is and how it helps with handling these, huge data sets?
Sure. Imagine you have this massive jigsaw puzzle.
Right.
Instead of trying to do it yourself, you give pieces to your friends and you work on it together.
I see.
It's kind of the idea. You split a complex task into smaller parts and give them to different computers. They work in parallel and, get it done faster. And that's crucial when you're dealing with these data sets that would just overwhelm a single machine.
Okay, so it's dividing and conquering, but with the data. What other complexities come into play when we're talking about these real-world applications?
Another really big one is latency. So think about algorithmic trading.
Okay.
Where split-second decisions, they can, make or break a deal.
Right.
Your model needs to analyze market data, generate predictions, super fast, with minimal delay. If it takes too long, you could miss out.
So it's not just about building an accurate model.
No.
It's about building a fast one, too.
You got it. And to get that speed, you might need to look into things like Edge AI.
Yeah.
Where you run the ML model directly on the device that's generating the data instead of sending it all the way to the cloud. This cuts down on that data transmission time.
Edge AI. That's something I've heard of, but I don't really fully understand. Can you break that down a bit more?
Of course. Um, Imagine a smart security camera, right? It needs to spot intruders, in real time. So instead of sending all that footage to the cloud, you can run a small ML model right on the camera. That way, it can make decisions right away without waiting for data to travel. That's edge AI.
So bringing the smarts closer to the source, that's fascinating. But with all this focus on like speed and efficiency, what about security and privacy, With all this sensitive data, how do ML engineers make sure it's protected?
That's huge, yeah.
Yeah.
ML engineers, they need to be on top of data privacy regulations, bake security into their systems right from the start. Think of it like building a bank vault,
Okay.
You don't just like add security later. It's part of the plan from the beginning.
It sounds like ML engineers need to be like experts in a lot of areas, not just the algorithm.
You're telling me. Data cleaning, distributed computing, edge AI, security, privacy.
Yeah.
And that's just the beginning. There's also the challenge of like keeping these systems running, uploading them once they're out there. That's where MLOps comes in, bringing those DevOps ideas to machine learning.
MLOps. Now that sounds interesting. What exactly does that involve?
So think of it like building a continuous integration and deployment pipeline for your ML models, automating things like training, testing, validation, deployment, monitoring.
So you don't just build a model and then walk away. It's about creating a system that can like adapt and evolve, you know?
Exactly.
But let's dive a little deeper into MLOps in part 2 of our deep dive.
It's like imagine building a self-driving car, right? You wouldn't just build it, put it on the road, and just like cross your fingers.
Right. Of course not.
You need a whole system to monitor its performance, find issues, make adjustments as needed. That's kind of what MLOps does, but for machine learning models.
So you're creating this feedback loop where the model's constantly learning, improving, based on real-world data.
Exactly. And this is where it gets really interesting, from an engineering perspective. It's not just about the model itself. It's the whole infrastructure, the processes to support that model throughout its entire life, like building a whole ecosystem for these models to thrive in.
Okay, so we've talked about like the nuts and bolts of bringing these ML solutions to life. Now let's shift gears a bit. Talk about the impact. It's pretty amazing to see, with all these challenges, how machine learning is already making a real difference in different industries.
Oh, absolutely. It's being applied in ways that, like, a few years ago we would have thought was science fiction. Healthcare, finance, manufacturing, you name it.
Let's start with healthcare. Many people, when they think machine learning, they think like self-driving cars. But it's making waves in, less obvious fields too. What are some examples of how it's transforming healthcare?
One area where it's having a huge impact is diagnostics. So imagine an AI that analyzes like retinal scans to spot diabetic retinopathy, which is, a leading cause of blindness.
Yeah.
And it does it with even greater accuracy than human doctors. That kind of technology could prevent vision loss for millions of people.
Wow. That's a powerful example of how machine learning can literally save sight. What other areas of healthcare are being impacted?
Personalized medicine. That's a big one. Using ML to analyze a patient's genes, their lifestyle, medical history to create these super personalized treatment plans.
Yeah.
This could totally change how we approach like chronic diseases, cancer, heart disease, leading to better treatments, better outcomes for everyone.
It's like bringing us closer to that era of precision medicine, right, where treatments are tailored to each individual. What about finance? What role is machine learning playing there?
Finance is using ML for everything.
Yeah.
Like fraud detection, algorithmic trading. Imagine a system that analyzes millions of transactions, in real time to flag anything suspicious. Could save businesses a ton of money. And on the trading side, think of algorithms that crunch huge amounts of market data, make super fast decisions, giving traders an edge.
So in finance, it's all about like speed, accuracy, and making sense of all that data to make smarter decisions. What about retail? I'm guessing ML is behind those personalized recommendations we see online all the time.
You got it. Recommendation systems are a perfect example. They analyze your browsing history, what you've bought before, to suggest things you might like, makes the whole shopping experience more personal. But beyond that, ML is being used for dynamic pricing, inventory optimization, helping retailers predict what people want, and adjust their strategies.
So it's like creating a more personalized and efficient experience for the shopper, but also helping the retailer run things better. What about manufacturing? Is machine learning having an impact there?
Absolutely. Manufacturing is being totally transformed by ML. Think about predictive maintenance.
Yeah.
Sensors and ML algorithms working together to, like, monitor equipment, predict when it might break down.
Okay.
This lets manufacturers do maintenance, before anything actually goes wrong, prevents downtime, keeps production running smoothly.
So instead of waiting for something to break, they can anticipate it and fix it beforehand. What other innovations are we seeing in manufacturing?
We're starting to see robots that can, like, learn and adapt in real time, thanks to ML.
Yeah.
Imagine a robot on an assembly line that can, change its movements, its actions based on the task, or even learn completely new tasks.
Right.
That kind of flexibility makes them way more valuable in a manufacturing setting.
It's like taking robots from like just mindless machines to actual intelligent collaborators, on the factory floor. This all sounds like really exciting. But we got to talk about the human element. With ML automating all these tasks, what does it mean for jobs, for the workforce in general?
That's a big question, and it's one we need to address head on. While it's true that ML might automate certain tasks, it also creates, like, new opportunities, new roles. The key is upskilling, retraining the workforce to prepare for these jobs of the future.
So it's about adapting, embracing these new opportunities. But how do we make sure this transition, this shift, benefits everyone?
Education, training, that's crucial. We need to give people the skills, the knowledge they need to succeed in this, NL-driven world. Not just technical skills, but things like critical thinking, problem-solving, creativity.
So it's not just about coding, right? It's about this broader set of skills that can adapt to this constantly changing tech landscape. But let's dive deeper into the skills and training needed for ML in the next part of our deep dive. So it sounds like the future of work in this, like, ML-driven world, it's going to need, a mix of those technical skills, but also human, ingenuity. But where do people, like, even start to get those skills?
There are several paths. I mean, traditional universities, they're trying to adapt, adding more ML course and stuff. But they often, they have a hard time keeping up. Things move so fast.
Right, yeah. So where else can people go for, like, more up-to-date training?
That's where these specialized programs, boot camps, they come in. These are really immersive, go way beyond just the theory. They give you hands-on training with the tools, the techniques, the best practices that companies are actually looking for.
It's like they're designed to get people, up to speed fast, give them the practical skills they need to, like, jump right in.
Exactly. Think of them like intensive training montages. For the ML world, people work on, like, real projects. They have mentors from the industry. They build a portfolio to show potential employers what they can do.
It's almost like an apprenticeship, but for, like, the digital age, right?
Yeah, that's a great way to put it. And the demand for these skilled ML engineers, it's only going up as ML becomes more, just more a part of everything.
Speaking of that, we talked about the impact on, all these industries, but what about, like, our everyday lives? How's ML going to change the way we live, work, interact with the world?
I mean, it's already happening in subtle ways. Those personalized recommendations on streaming services.
Right.
Or spam filters in our email. But as things advance, I think we'll see even bigger changes, more transformative applications.
Like what? Can you give us some, like, concrete examples? How ML might actually change our daily routines in the future?
Imagine a world where, like, your smart home, it knows what you need before you even do. Adjust the temperature, the lights, the music to, your preferences. Even makes your coffee just the way you like it.
Oh, nice.
All because of, ML algorithms that have learned your habits over time.
It's like having a personal AI butler.
Yeah, kind of. And beyond that, think about personalized education. Systems that adapt to each student's learning style, how fast they learn. Algorithms could analyze their strengths and weaknesses, tailor the whole curriculum to them.
That would be a game changer for education, letting every student, reach their full potential. What about transportation? We've talked about self-driving cars, but how else might ML impact, like, how we get around?
Imagine a world where, like, traffic just flows smoothly. No more gridlock.
That would be amazing.
All thanks to ML-powered traffic management systems. They analyze real-time data, optimize traffic signals, to reduce congestion. They can even, like, suggest alternative routes or even different ways to get there based on your destination.
So no more wasted time stuck in traffic. It's incredible to think about all these possibilities. But as ML becomes more powerful, more embedded in our lives, it also brings up some big questions.
Oh, absolutely. We got to think about the ethical implications. Make sure it's used responsibly for the benefit of everyone, not to, create new problems or make existing inequalities worse.
It's about finding that balance, right, between all this amazing innovation and being responsible with it.
You got it. It can't be one or the other.
Well, I think it's safe to say that the future of machine learning, it's incredibly exciting. So much potential to, you know, change industries, reshape our lives, even how we think about the world. But as we've talked about, we got to approach it thoughtfully, responsibly, making sure it's used to, well, make a better world for all of us.
I couldn't agree more. The future of ML, it's in our hands. It's up to all of us to shape it in a way that benefits everyone.
This deep dive has for sure opened my eyes to all the possibilities and the challenges that, are ahead in the world of ML. And to our listeners, I hope this has, made you curious, inspired you to learn more. Who knows, maybe you'll be the one building the next big ML application.
The possibilities are, well, they're pretty much endless. So keep learning, keep exploring, and keep pushing the boundaries of what's possible with machine learning.
And on that note, that wraps up our deep dive into machine learning in 2025. Thanks for joining us.